So we've now built a pretty complete set of circuit analysis tools. We have Ohm's law, we have Kirchhoff's laws, we have the ability to combine resistors in series and parallel. We also have current division and voltage division. Believe it or not, that set of tools is sufficient to solve a lot of problems. Not exactly all problems. There are a few that it won't work with, but that's enough to do an awful lot. Now, there's one thing that's going to come up in the problems that you're going to be facing from now on. And I wanted to give you a complete lesson on this thing because it's so important. I'm calling this simplification and reexpansion. Now I've got to say, this is probably not going to be a term that you're going to pick up in a circuits textbook. That's a term that I've kind of really invented, but I wanted to prepare you for the fact that what we're going to do is we're going to simplify the circuit to get it down to maybe just an application of Ohm's law or Kirchhoff's laws. And then we're going to go back to an earlier version of the circuit. And the reason why we have to go back to the more expanded or more complex version of the circuit is that when we combine resistors in series and parallel, it's going to eliminate some variables that we might need to keep. Maybe the target variables that we're trying to calculate may actually disappear from the circuit. And if that happens, we have to go back to an earlier version of the circuit that still has those target variables. The analogy that sticks in my head, and it's not a perfect one, is that you start with like a Neanderthal, and the Neanderthal sort of becomes the modern human. The modern human invents a computer or a cell phone, and then we find a way to get it back to the Neanderthal. And so we start with a very primitive version of the circuit, a very early, very complex version of the circuit. Then we simplify. We make some analysis, get some new information, and then we take it back to the earlier versions of the circuit. That's probably not going to make a lot of sense until you see some examples. And I have to warn you that you're probably going to get tired of examples. If you get it, if you totally understand this, this is one of those places where I'm probably going to give you more examples than you need, but I want to give you enough to make sure that you understand everything. So here we have a voltage source, 40 volts, with a resistor, 2 ohms, a 12 ohm resistor, and a 4 ohm resistor. We're asked to find I1 and I2. Now I got to warn you, here comes one danger place where every year students look at this 40 volt source and they see the 2 ohm resistor and they're asked to find this current and they say, oh, it's obviously 40 volts divided by 2 ohms. That's 20 amps, problem solved. Except it's totally not solved. What that means is that you've just used your whole 40 volt source across this 2 ohm resistor. And you are now dead in the water right here past the 2 ohm resistor. You have no energy, no voltage left to get past the 12 ohm source or past the 4 ohm source and back to the other side of the voltage source. But you always have to have enough to get back to the 40 volt source. You always have to complete the loop or complete the circuit. That's why it's called circuit analysis, because you're always completing a circuit. So if you use the whole 40 volts across this 2 ohm resistor, it's kind of like a person who is asked to run a marathon, sprints for the first mile, and then doesn't finish the race. Here you're only 1 mile into the race, maybe 10 miles into the race, but you're definitely not done with the race. You've got to get all the way around back to the beginning. You got two choices. You can go through the 12 ohm, you can go through the 4 ohm. We know enough to know that most electrons are going to go through the 4 ohm resistor, but either way, you have to get back to the other side of the 40 volt source. I know that some of you are going to be tempted to do this 40 volts divided by 2 ohms. Some of you will even do it on the next exam, and it'll break my heart. So just remember, don't do this. What we have to do instead is find the total resistance that's seen by this voltage source. Then divide the voltage source by that total resistance, and that will give us the current, the I1 that we're looking for. So what can we do first? Well, the very first thing we can do is combine these two resistors in parallel. So 12 in parallel with 4, that's going to be 12 times 4, 48, divided by 12 plus 4, 16. 48 divided by 16, that gives us 3. So this is one of those places where this equation becomes very second nature. You may not even need to resort to your calculator to do it if the numbers work out to be even. But notice what happened when we combine those two resistors in parallel. I2 disappeared from the circuit. I have no place in figure B that I can draw I2. It doesn't exist. The 3 ohm resistor has elements of the 4 ohm resistor and elements of the 12 ohm resistor, but they're combined. And so therefore I cannot show I2 in figure B. This is what I mean when I say that maybe your target variable disappears. Now I can combine the 2 ohm and the 3 ohm resistor. That's no problem. I end up with a 5 ohm resistor. Notice that I1 really remained unchanged. I1 was in the top left corner. It remains in the top left corner. And the 5 ohm resistor is just here on the right hand side of the circuit. Now we apply Ohm's law. 40 volts divided by 5 ohms gives us 8 amps. And so therefore 8 amps is the value of I1. So I can scroll down here to equation 1. 40 volts divided by 5 ohms gives us 8 amps. We've definitely solved for I1. Now, I1 is the only thing we can calculate in figure C. We can go back to figure B, and that's still the only variable that's listed in figure B. But if we go back to figure A, I1 still has that same value of 8 amps. So I now know more information than I knew before. I know everything that I knew before, and I know that I1 is 8 amps. By the way, remember when I said 20 amps was going to be too much? 8 amps is exactly right. That's like if you have a budget for your vacation and you use the very last dollar to buy the last gallon of gas to get back to your house, that's what would happen with 8 amps. So I know that I1 is a current that's flowing into this node. I apologize for the rough looking arrow. I also know that there's a current flowing downward that I don't really care about. And then I know that there's a current I2 that's flowing to the right, which I care very much about. And I know that these two currents are going to split this total current that's coming in from the left. And I know that those two currents go into two resistors that are in parallel. That's the classic example of current division. So I can now use current division to find I2. So I2 is going to be the total current multiplied by the ratio of the other resistor, 12 ohms, divided by the sum of the two resistors, 12 ohms plus 4 ohms, and that's going to give me I2. So if I scroll down here to equation 2, you can see that I have I1 times 12 over 4 plus 12, 8 times 12 over 4 plus 12 gives me 6 amps. So I've now found the two variables that I was asked to find. I1 is 8 amps, I2 is 6 amps, and the problem is done. So we had to go from figure A to figure B to figure C to do the simplification. But once we got the key result from figure C, we had to work our way back to figure B and then back to figure A. Only then could we find the value of I2. Okay, so you now have enough information to tackle the first example problem, Simplification and Reexpansion 1. There will be 3 examples from today's lesson. This is the first of those 3. I would encourage you to try that example from start to finish and only then watch the video. I know that sometimes it feels like you should watch the video while you do the example. In this case, if you would, try the whole example and then watch the video to see if you got it right. And I think that's a much more effective way of tackling this problem. You're going to have today to work on this sort of problem. Then next time we'll have a circuits working session, and then that'll really cement your expertise in this area.